Final solution that resulted from the testing and experimentation was a 15-inch outer diameter wheel which weighed about 1.77 pounds per tire and rim. The original goal of this project was to deliver a new set of 10-inch wheels to the Rover team. This original design was completed and we were able to manufacture a set of four that weighed 1.55 pounds each, which was delivered. However, through the testing we saw many issues where the Rover was too close to the ground and would get caught on taller obstacles. So through the means of our customer, we increased the scale of the design to the 15-inch size. This led to manufacturing issues since UTA know the Rover team contains a print bed that is capable to print this size. So we have been reaching out to the 3D printing companies to see if they're able to print the new set of wheels for us. I will pass it on to Clayton where he will dive into a deeper discussion of the rim design.
Our rim uses a radial spoke design to support the outer rim with higher stiffness values. The material we used is 3D printed PA12, which is a nylon plastic known for its toughness, impact strength, tensile strength, and ability to flex without resulting in fracture or failure. The wheel has an overall diameter of 6.5 inches with a half-inch inner thickness and a quarter-inch outer thickness. The final weight is 0.57 pounds per rim, which reduces the weight drastically when compared to aluminum. The manufacturing of the rims took place in the UT machine shop with help from Rex Winfrey. Upon testing the rim with structural analysis in SolidWorks, a factor of safety of 2.9 was concluded under maximum loading conditions. Now Kevin will cover the tire design.
TPU is a high-strength rubber-like material that can be used for additive manufacturing. Given its material properties and ability to flex without tearing, TPU 85A was selected. A hexagonal or honeycomb pattern was implemented into the tire design since it is the strongest shape in nature, as well as an infill density of 20%, which was obtained by adjusting the material's density in SolidWorks based on the infill percentage. This yielded a minimum static load factor of safety of 1.7. Given the results from testing of the previous tire, which can be seen in the top right, the tread depth was increased from 0.125 inches to 0.5 inches. The tread pattern was designed to offer better traction, and overall, the improved tire design had a weight of approximately 1.2 pounds. I'll now pass it on to Cameron to talk about our field testing.
Thank you, Kevin. Nearly every weekend this semester, our team has been collaborating with the Mars Suspension team to test our designs around campus and at local parks. Our wheels did not show any signs of plastic deformation, other than the expected wear and tear on the tire tread. However, these tests did bring the ground clearance issue to light, an example of which can be seen by the circled sections in the top right photo. This was a scenario where the right side suspension bottomed out, keeping the tires from coming into contact with the ground. I will now pass it off to Adam to talk about our conclusions.
On behalf of the Texas Mars Rover team and in fulfillment of our project, a full set of four 10-inch diameter revamped wheels was delivered to them. We leave the Rover team with a wheel design that is feasible enough to be manufactured in-house at a lower cost and significantly lower weight than what was first presented to us with the commercial off-the-shelf wheels. Through the expense of this project, our team learned that design can and should always be improved. So with this in mind, for the future of our wheel design, the upscale version of the wheels presented by our team is currently in works to hopefully be sponsored and manufactured by a 3D printing company for the Rover team in the future. I will now pass it back to Cameron with the greater impact of our project.
Thank you, Adam. During the course of our degrees, we have all learned about the technical and economic aspects of engineering. However, over the course of our senior design projects, we have become aware of the greater impacts that our designs and products can have on the communities around us, or even the possible global impacts on large-scale projects. Our team recognized early on that if our design were to fail, the time, effort, and money the Rover team put into this project would be wasted, and not to mention the potential damage which could cost the Rover team more time and money to fix as a result of our wheel failure. On a larger scale, a very similar example of this can be seen with the wheels from NASA's Curiosity rover, which suffered the failures seen in the image on the screen. These failures led to the rover not being able to complete its full mission agenda due to the possibility of the rover becoming immobile. These types of greater impacts are what drive engineers to strive for perfection, and were in our team's minds throughout the past year. Our team would like to thank and give special recognition to Dr. Alan Bowling, our faculty advisor, as well as Jason Cabrios and Hunter Smith from the UTA Mars Rover team for all of their advice and feedback over the course of our project. We would also like to thank Rex Winfrey from UTA's machine shop for assisting us with all of our manufacturing needs, Dr. Robert Woods for his advice on our rim design and analysis methods, Dr. Robert Taylor for his additive manufacturing expertise, and the Mars Suspension team for their assistance in creating a collaborative effort to conduct and document field testing alongside our team. Without the help of all of you, our project would not have been as successful. Thank you very much.